Welcome to Geography 485 585L, Internet Mapping, Module 4.3, Interoperability Standards, Desktop GIS Integration. This week we will be discussing the model for being able to access published Open Geospatial Consortium services in desktop geographic information systems, with a focus on the general model for performing that integration in terms of using the results of a GetCapabilities request to allow the client to configure itself to interact with those services, and then providing examples both in Quantum GIS or QGIS, the open source GIS application, and also a brief demonstration in ArcGIS that also outlines the methods for being able to go through the process of integrating OGC services into that platform. So at the foundation, there's a common model for configuring desktop GIS applications to effectively communicate with Open Geospatial Consortium services. And that model is based upon the GetCapabilities request and the XML document that is returned as the response to that request. So as we've learned from working with the GetCapabilities requests of a variety of OGC services, there is a large amount of information that is encoded into the XML file that is returned by any given OGC service, with the contents of that response then actually being usable by the desktop applications to obtain the information that is needed for them to configure themselves to effectively interact with those remote OGC services. So the common model is one where you provide to the desktop application one of two variations of a GetCapabilities request. The first model is where you only provide the base URL or web address that the OGC GetCapabilities request would be sent to, where the client application then adds to that base web address that you provide the required OGC GetCapabilities parameters, including the service type and the request type. The service being either WFS, WMS, or WCS, and the request being GetCapabilities, depending upon the service type that is being added to the client. Other clients can be configured to use a complete GetCapabilities request that includes all of the required parameters as a part of the information that is provided to the client. In the case of both Quantum GIS and ArcGIS, the first model is the one that is used, where there is a base GetCapabilities request provided. As an illustration of the distinction between the full GetCapabilities request and the base request, we can look at these two GetCapabilities requests for existing web map services. The first hosted by the Jet Propulsion Laboratory for an imagery collection that they host via WMS. The second for the USGS Framework Data Web Map Service, or WMS. And you'll see that in both instances, the web address includes the base URL, which we can see as essentially the portion of the web address that precedes the question mark in the web address, where the WMS request parameters follow the question mark. A similar pattern can be seen in the USGS Framework WMS, where the base URL is everything to the left of the question mark, and the request parameters the parameters that are related to the particular WMS GetCapabilities request that is being submitted are on the right side of the question mark. This is commonly found, but not always the case. As you may have noticed with some of the web map, web feature, and web coverage services that we've looked at over the course of the semester, there are some services that include some of their own parameters to the right of the question mark. And in those cases, you would need to also include those parameters that are not the OGC WMS, WFS, or WCS parameters as a part of the base URL, because that is information that is required by the server. This is an instance where it is important, if you provide the base URL and your client is not able to successfully configure itself to interact with the service, you should examine the GetCapabilities request itself to see if there are any discrepancies in terms of the URLs, the online resources that are provided as a part of the XML GetCapabilities document that is provided, so that you can work on troubleshooting the connection that your client application is trying to make. Remembering that all of the information that your client application is using is being derived from the XML document that is provided by the service. Unfortunately, there are quite a few services out there that do not have complete service metadata included in their GetCapabilities request. Metadata that you might have been able to read and interpret using your own visual and interpretive skills, but values or information that are either incomplete or inaccurate, that when your computer tries to read that information and use it to configure a connection to the service, may not succeed in doing so. This is something you want to keep in mind as you experiment with bringing services into a desktop client. And always remembering that you can fall back and look at the capabilities request itself and even test it in a web browser to see if what you are trying to do actually works through a manual request that you can compose, just as you have done for some of our previous homework and lab assignments. So here again, we have the full GetCapabilities requests that are part of the service that is provided by either JPL or USGS. When we translate these into a base URL, we are essentially stripping off everything to the right of the question mark as a part of these base requests. Again, keeping in mind that some services may have additional parameters to the right of the question mark that are non-WMS parameters or WFS or WCS parameters that you need to also include as a part of the base URL. This is why you need to know what the OGC request parameters are so that you're able to identify from looking at a GetCapabilities request what parameters relate to the WMS, WFS, or WCS request, and which parameters might instead be related to the service itself that you're interacting with. In the case of both JPL's service and the USGS service, these do not have any additional parameters as a part of their web map service, and as a result, the base URLs are simply everything to the left of the question mark. So these are the two URLs that you would provide to both Quantum GIS and ArcGIS as the GetCapabilities request that they would then try to use to configure themselves. As I've already said, Quantum GIS, as we begin to address the specific process for working with Quantum GIS, uses the base URL approach for adding either web map or web feature services to a particular project. QGIS does not support web coverage services at this time, and web feature services are added and may be added only after you enable the WFS plugin, which is installed with Quantum GIS, but there's actually a checkbox to enable it within the plugins manager. So the general process that you would follow when adding a new web map or web feature service to Quantum GIS is to essentially add a new service to your current Quantum GIS project, or select an existing service that has previously been added. Remembering that as you add new services to Quantum GIS, they continue to be available in new map projects as you create them. So you only need to add a service once, and you can then continue to reuse it in new mapping projects within Quantum GIS. For each service, you may have one or more layers that are advertised by that service. So the second step is typically to select the layers that you want to add to your map. And then the third is to add the layers by actually having selected them, saying OK in the dialog where you're interacting with the service. So related to that first step, in terms of adding services and adding layers, the first thing you need to know is the GetCapabilities request for the service that you want to add. So here, for example, we see the USGS Framework WMS service that we were looking at as an example earlier. You can always check the response to this metadata to look at the online resources to see what the base WMS request is, the request without the additional parameters. But you can also truncate the existing GetCapabilities request to everything to the left of the question mark as what you submit to Quantum GIS. Within Quantum GIS, WMS is enabled by default, and the WFS plugin must be enabled through the Manage Plugins option in the Plugins menu. Once you have enabled the WFS plugin, you can add either a WFS layer or a web map layer, web map service layer, directly from the layer menu, or from the menu items within the interface, the map interface itself. And that's what we will be showing in the demonstration. So, once WFS is available to you through the plugin being enabled, you can either select Add WMS Layer from the layer menu, or click the Add WMS Layer or Add WFS Layer from the buttons in the interface. Either one of these actions would then bring up a dialog box where you can provide a new GetCapabilities request or access previously created services within the application. So, if you have not yet added the service that you're interested in using layers from, you can add that new service through the dialog and save the configuration. Otherwise, you can select an existing service, and then once you have selected that service and retrieved the layers, you can then select the layers that you want to add from the dialog as it displays them in the window. And you can repeat this process for each layer that you want to add to your map. So as an example, we can look at a configuration file that I've already created and saved for Quantum GIS, which is linked from this demonstration page in the lecture notes. So if you would like to experiment with this particular example yourself, you can click on the example link at the top of the slide, where we see here a screenshot of the interface within Quantum GIS showing some of the web map and web feature layers that I have pre-configured within this QGIS configuration file. So when you open up Quantum GIS and open up this configuration file, this is the default map view that you will see. And if you haven't worked in Quantum GIS before, the layout is somewhat like other GIS applications, where you typically have a table of contents area here on the left-hand side by default, and then you have a map area that is showing the current map. And you have a set of tools across the top of the map window that you can interact with. And you can hover over those tools to see tooltips about what those individual buttons allow you to do. These arrows, these gray arrows, indicate that there are additional menu options that are not displayed because there's not enough room in the menu. If you click on them, you will see a list of icons for additional activities or functions that are available to you within the application. In our case of working with web map and web feature services, we're interested in this add layer collection of options, where if I click on the gray arrows to expand that list, we can see a number of icons that represent the ability to add different layer types to the map. The two layer types that we are particularly interested in are the web map and web feature services and the capabilities that are provided within QGIS for accessing those. The two icons that provide access to the ability to add new web map or web feature services are first this icon that looks like a globe, which when you click on it will bring up a dialog that shows provides access to the current list of web map services and also allows you to add new services. And then this other icon that looks like essentially a globe with some line art on it that is actually, if you look very closely, it looks like North and South America as continental boundaries on a spherical globe with no background image. By clicking on this, again, you would bring up the dialog box that allows you to view the existing web feature service layers or add new ones. So let's start by looking at the existing layers that I have within the mapping client. In this case, you can see that I have 5 layers that are a part of this mapping client. I have 3 image layers as indicated by this red, green, blue little line at the bottom. Those are suggesting those are imagery layers. And then I have 2 polygon layers or vector layers on top, indicated by this purple and blue rounded polygon. Keeping in mind that WMS provides map images and WFS provides the actual data and the associated attributes. So right now we only have one of these layers enabled. The same imagery service that we've used in some of our other WMS demonstrations. This is an imagery service that is hosted by New Mexico ArcGIS and includes a variety of imagery data that are available at a number of different scales and resolutions. I could enable this Modus Fire data set. And if you look down at the bottom of the screen, you can see that it loaded it, and it looks like there are no current fire data that are being published by this particular service at the moment. Or we can click on this additional data set in terms of vegetation coverage that is hosted by NASA's NEO system. So this is a vegetation classification system, and we're looking at a web map that represents the vegetation classification. So I'll turn those off, just reminding you that each of those is a service that is hosted by a remote server where they are delivering map images back into the client. I currently have no locally stored data for any of these web map services, as those map images are dynamically generated and delivered by the remote services as I request them. This is in contrast to the two web feature services that we have, where these are actually both web feature services that are hosted by also by New Mexico ArcGIS, where if I turn on the layer for game management units, these are the game management units for New Mexico, and I can actually see that I have downloaded the vector data and their attributes by going to my toolbar and choosing the Identify tool, which requires me to first select a layer. Now I can choose the Identify tool, and I can click on any of these and see the results of the query for that particular polygon. In this case, we're seeing the attributes for this particular GMU or game management unit. If I click on another polygon, we see the attributes for that, and you can see how it is highlighted in the interface. These are all byproducts of the fact that the actual polygons, the geometry, and the associated attributes have actually been downloaded to my local system as a result of the web feature service request for that particular data set. Likewise, I can enable the New Mexico property tax districts and also click on any of those and see the attributes for those property tax districts. That would be, of course, after I select the tax districts layer and then click on them, and then we can see up here, now we're seeing the attributes of the property tax districts layer. And as we've seen in our other interactive maps, these services within the desktop GIS are dynamic in that we are actually able to see the data as we zoom in and zoom out and interact with the map. So if I zoom in to the area around Albuquerque, the imagery layer that we have requested from ArcGIS is refreshed, just as you saw in Google Maps or Google Earth. When you refresh the map, change the map area, the new map images are requested and displayed. And you'll see also here the example of the different imagery layers that are a part of the imagery collection that is being hosted by ArcGIS. So as we zoom in further, we still see these layers. If we zoom in further still, we eventually change over to another collection of imagery that is at a higher resolution, and we can continue doing this. All the while, because of the WFS request model, we still have the data for our tax districts, for example, which of course now we're within a very small area, so we're not seeing the dimensions of those tax districts. I can choose to zoom to the layer extent, and that will take us back out to the statewide view. as the map refreshes. You can always see down in the lower corner of the display an indication of what is happening in terms of the interaction with the remote server. So you saw first that the map was being requested via WMS, and then it tells you how many bytes of map data were downloaded. And you will eventually see that all of the bytes of map data were downloaded, knowing that it has completed rendering. So let's look at what the dialog boxes look like for our web map and web feature services so that you can see what the interface consists of when you want to add or interact with services that have been added to QGIS. So here we can click on the WMS icon. After clicking on the icon, the Add Layers dialog will come up, and you'll see a number of options within this dialog. First, you'll see an option that shows a dialog, part of the dialog that shows the existing services that are available within QGIS. These are services that have been previously added or that are a part of the current project. So in this case, you can see that we have a number of services that have been added to this particular web map service already. And among them being the NASA NEO WMS and a quad hillshade data set and a Valencia County mosaic shapefile, a number of different data sets, each one of these representing a particular web map service that has been added to the system. If we choose this EDAC BMNG, we can actually choose to edit it. And what you see here is information which is the same information that you would enter to create a new service, where you provide that service a name, and this is a descriptive name that you would provide that will show up in that menu, and you provide then the base URL for the GetCapabilities request. If you happen to be interacting with a web map service that requires a username and password, you can enter those as well. We haven't encountered any of those in any of the services that we've been working with, but they do exist out there, and as you read the information about a particular service, you might see notations about some sort of authentication being required and processes for obtaining a username and a password for a particular service. If you encounter that, or if you have a username and password, you can enter those here as a part of the configuration for your WMS connection. So if I were to choose new, as I said, we see a new connection dialog where we can enter again a name that we would like to give the service, and then the GetCapabilities request that we would enter in the URL, where that is the base GetCapabilities request. If you'd like to delete a particular service that you've added, you can do that as well. Once you have either created a new service or selected an existing service so that the service that you want to interact with is shown here in the dialog at the pick list here at the top of the dialog, you then click on the Connect button. When you click on the Connect button, QGIS then executes the GetCapabilities request and retrieves the list of all of the layers that are a part of that particular service. Until you click on the Connect button, you have only registered with Quantum GIS the information needed to interact with the server. Once you click on the Connect button, you actually are seeing the current set of available layers for that particular service, and you can adjust the width of the columns to be able to see the different pieces of information in terms of the numeric identifier the name that would be used in composing a new WMS request, the human readable title, and any abstract that's been created for that layer. You can then select one or more layers to add to your map. And so if I wanted to, for example, add this Blue Marble Next Generation 8-kilometer data set, I can just click on it. And once I've selected it, I can see down here at the bottom the coordinate reference system that's available for that particular data set, and then give that layer a new name as it will be added to the map. So if I wanted to call this global satellite, global image, I can change the name. I can also choose the format of the image to be requested. So this is where, depending upon the type of service you're interacting with, you may want to choose an image type that supports transparency or not. In this case, I'm going to choose JPEG because this particular layer is an imagery layer, and I don't necessarily care about transparency at this moment. I can then choose Add, and you can see that the global image has been added to my map. And just as we've seen in some other examples, since I chose a JPEG as the format, which is a format that supports imagery very well but does not support transparency, it looks like I may be outside of the scale range for this particular layer, where if I zoom to the extent of that layer, I can now see the entire layer and confirm that I'm actually interacting with that service. So with the web feature services, the process is exactly the same. You click on the web feature service layer icon, and that brings up a dialog where you can then either create a new connection to a web feature service, edit an existing one, or delete an existing one. In this case, I can see that I have created a number of existing web feature services. So if we choose New Mexico counties and edit it, you can see I've already created a name for this, and it's NM Counties WFS. And we can see that I've also added the base URL for the GetCapabilities request for this web feature service. As with the web map service, if there's an optional username or password required by the service, you can add those as well. Otherwise, you can leave them blank. So we'll say OK here. And as with the web map service, I want to then connect to the service to do the GetCapabilities request to get the metadata about the service. And we can see here that we have one feature class, one feature type as a part of this web feature service. And it's highlighted by default. So I can highlight this, and I can see the coordinate reference system down here, and I can change that if I like. And I also have the option of only requesting features that overlap the current view extent, which is a really important feature when you're working with some data sets that may be global and very large, where you may only want to work with a subset of the data that relate to your area of interest. So if we cancel out of this for a moment, and I zoom back to an area just in New Mexico, since we're looking at a counties data set, and even more, we zoom into this area surrounding Bernalillo County. So after zooming into the area around Bernalillo County, we open up our web feature service dialog box, and for example, choose the New Mexico Counties web feature service. We can choose to connect and either request all of the features, or in this case, only request features that overlap the current view extent and say OK. You'll see that we then submitted the request to the server, and if we zoom out, we only have the polygons for the counties that overlapped our area of interest, which can greatly streamline the speed of download and the amount of data that you may be managing locally. If you're only interested in a particular area, you can obtain that spatial subset by just choosing that option in the Web Feature Service dialog. And as we've seen with the data that have been delivered as a part of the other web feature services, we can choose the Identify tool and click on any of these features and see the attributes of any of these polygons. And in this case, we have very little information about these counties. But the principle still applies, where you can essentially have the actual geometries themselves and their related attributes as an alternative to a web map service where you just might have a visual representation of the county boundaries. We could add an additional web feature version of the same data by connecting to it again and leaving this only request features overlapping the current view extent off and choosing OK, where now the entire data set has been loaded. And you can see that in contrast to the previous request. And of course, the other option you have, since you actually have the geometries, you can actually modify how those polygons are rendered by using styles, which you don't have the same options when interacting with some web map services. So in this case, we could even have, say, some sort of hashed fill pattern, where maybe the fill color is yellow, and choose OK. And now we've been able to have two layers from the same web feature service, one of which represents a subset of counties where we've styled that in one way, and the other representing all of the counties. And this is possible because we actually have the data from the web feature service locally stored within our client and in a form that we can even use to save those data. So I can right-click on these layers, and I can even do a save as to save it as a local shapefile, so that if I want to continue to work with the data locally, perhaps if I'm offline, I don't have access to the internet, I can actually save the file locally as the data that have been delivered as a part of the web feature service. The approach within ArcGIS is similar in that you basically provide a base URL that represents the GetCapabilities request and submit that to ArcGIS as a part of the configuration for any OGC layers that you would like to add to ArcGIS. Let's talk a little bit about the configuration of ArcGIS for a number of services, including ArcGIS WebMap, Web Feature, and Web Coverage services, starting with ArcGIS WebMap service support. Within ArcGIS, the process is somewhat straightforward, but it typically involves a number of steps for adding any of these services into ArcGIS. The first is to actually click on the Add Data button within the ArcGIS ArcMap environment, circled here in the screenshot. With that, a dialog will come up where you can then choose GIS servers from the list of available locations to look in for data. Once you choose GIS services, you can choose to add a WMS server, or you can choose a previously added web map service server that you've added through a previous interaction through this process. So in this case, we're choosing to add a WMS server, where a dialog comes up that is not terribly different from the dialog that we were seeing in Quantum GIS, with the difference being that we don't here have the option to modify the name of the layer that's going to be added. In the URL field, we add the URL for the base GetCapabilities request, and once we have done that, we can then click on the Get Layers button to have ArcGIS actually execute the GetCapabilities request, which then populates the rest of the dialog with the information about the various layers and their capabilities. Once you've successfully connected to the ArcGIS, the web map server, and successfully executed a Get Layers command, you can then click on the OK button to add that new web map service to the list of available services in your ArcMap ArcGIS environment. The ArcGIS Web Feature Service configuration is slightly different in that it currently requires that the data interoperability extension be installed as a part of your ArcGIS installation. This is something that has to be typically done as a separate installation when you install the software. So if it has been installed, it shows up as an option in the extensions dialog in ArcGIS. The key is that even if your license does not allow you to enable the data interoperability extension, you still need to have it installed. You just don't enable it by checking the box next to it. Just by virtue of it being installed, you now have WFS support within ArcGIS. So connections to web feature services are through ArcCatalog's interoperability connections area, which you can get to both through the Add Data dialog or through a dedicated button in the toolbar for ArcMap. So if you're in ArcCatalog and you choose to add an interoperability connection, then you see a dialog that allows you to provide the parameters for defining the characteristics for that web feature service connection, where it appears at first blush to be a fairly simple dialog where you can specify the format as being a web feature service, where you choose that by clicking on the little button next to the format field that brings up the options to choose the format that you want to add. Choosing web feature service, which granted is not very visible in the dialog box that you see on the slide here, but it's one of the two options that you would have if you have the interoperability, the data interoperability extension installed, but you don't have the license for it. You also provide in the dataset field the GetCapabilities base URL, for the service. And then you need to click on the Parameters button to set additional parameters for the data set. That brings up a dialog box where you can set additional parameters as a part of the configuration of the web feature service. With the key thing that you want to do here to choose the table, essentially the feature type that you want to add for the web feature service, from the table list area under the constraints for the web feature parameters dialog. That will bring up the feature types that are hosted by that particular service based upon the GetCapabilities request that was submitted to the service based on the URL that you provided on the original dialog. And you can check the boxes next to any of the layers that you would like to add from this particular web feature service, and then click on OK. They will then be listed in the table list under constraints. And you can click on the OK button in this dialog to choose those as the layers. One of the other things you might notice here is a way to specify the maximum number of features that will be returned as a part of interactions with this service. Many web feature services have their own limitations in terms of the maximum number of features that they will return, but you can also define for yourself the maximum number of features that you will ask for from the service, which can help to prevent sort of a runaway request to a service that might result in hundreds of thousands or millions of features being returned to you that may just crash your system or just seem like it never completes. So once you have gone through that process, the connection that you've defined will appear under the interoperability connections that are available when you choose to add data to a layer. And that's basically the process where you can, once you've created that interoperability connection, access it. Finally, let's talk about the WCS configuration in ArcGIS. The WCS configuration is actually much like the Web Map Service or WMS process, where it is also related to the GIS servers area under the Add Data dialog. So it's a much more straightforward process than we just described for the web feature services. So you choose the Add Data button in the ArcMap interface. That will bring up the Add Data dialog, where again you want to choose GIS servers from the location where the data will be looked for in that Look In pop-up list. You want to choose GIS servers. And in this case, you can either choose an existing WCS service that you have previously added, or you can, as is illustrated in the dialog box here, choose to add a WCS server, where you go through a similar process as we did with Web Map Services, where you add a WCS server in the dialog by providing the base GetCapabilities URL in the URL field, and click the Get Coverages button once you've provided that URL, so that the dialog will provide the initial connection to the remote web coverage service to obtain the list of available services and coverages for that service. Once you've successfully done that, you can click on the OK button, and the service is then added to the list of services that are available under GIS servers in the Add Data dialog, where you can then select that particular service, and then once you've selected it, it'll bring up a list of the available coverages for that service that you can select from to add to your map. One thing to keep in mind, particularly when working with web coverage services, is that the implementation of web coverage services, both in terms of servers and in terms of the client implementation, is still fairly immature in that there are a number of test WCS services out there, but they aren't necessarily very stable or very comprehensive. And likewise, the data format support for ArcGIS, for example, may not align with the formats that are published by particular web coverage services. So you may encounter, if you're experimenting with adding web coverage services to your map projects in ArcGIS, a fair number of instances where you can attempt to connect to a web coverage service and even add a web coverage service layer to your map, and find situations where those coverages are not successfully added to your map. So it's just a matter of experimentation and tracking with the continued evolution of both the client implementations and, even more importantly, the server implementations that are publishing these web coverage services. So there's still a lot of potential that in many respects is not quite realized when it comes to web coverage services, their availability, and the ability of client applications to use the products of those web coverage services. That having been said, I do have an ArcGIS MXD file that is linked here from the demonstration page that you can download and experiment with in your own ArcGIS installation, so you can see how these OGC web map and web coverage services perform within the ArcGIS environment. And in this case, this MXD includes layers that are hosted by the Alaska Mapped website, where this is a collection of geospatial data for the state of Alaska. And you can download the MXD file that I will be showing here from the link on this slide. So here we're looking at the ArcGIS interface, and we can see on the left-hand side, I have two layers as a part of the interface that are based upon layer files that are published by Alaska Mapped. And I can, just as with any other layers in ArcGIS, turn them off and on, and even drill down and see additional information about, say, this web map service, where we can see, if we expand this table of contents a little bit, we can see that they actually have a number of different web map service layers that are a part of the service. And you can see the checkboxes are either dark or grayed out, where the dark checkboxes indicate that that particular layer within the web map service is within the scale range defined for that layer. You might remember from our earlier discussion of the scale element within the GetCapabilities request. This is an instance where ArcGIS is reading that information from the GetCapabilities request and modifying its user interface to indicate the specific layers that are inside or outside of their particular scale range. And we can turn on or off the particular layers that are available as a part of this service, just like you can with any other layers within ArcGIS, with the difference here being that these are actually map images that are being delivered as a part of the web map service that is published by Alaska Mapped. Likewise, we can look at this spot DEM data set that has been delivered as a product of a web coverage service call to their service. So if we zoom in to the area of the data for this catalog service, we can see the map image behind from the web map service was refreshed, and you might have noticed in the lower left corner an indication that that map was being refreshed. And we now have a better view of this digital elevation model that came from the WCS, keeping in mind that since the WCS provides the actual gridded data and not just a picture of the data, we can treat those data just like any other raster data set that we have in ArcGIS. So if I right-click on this particular layer and go to the properties for that layer, I have all of the options for that layer that I would have for any raster. So for example, I can go to the display and apply some effects to that particular layer. I can go to the extent and see the information about this layer in terms of the full extent and so forth about this particular layer and the current visible extent. I can go to the General tab and set scale limits for how this layer or when this layer should be displayed within my client. And I can modify my symbology. So you can see here there's a color ramp that has been added to this, but since I have the actual data associated with that, I can choose my own color ramp. So if I prefer to use this grayscale color ramp and then apply it, you can see in the map that I've been able to change the display of the data because I have the actual data values. So these are the benefits of being able to actually execute this web coverage service request to the remote system and bring the data in for my particular area of interest as a part of the configuration within ArcGIS. And you can do that by going through the process that I outlined for each of the types of OGC services that I just finished talking about. But these are just some illustrations of how these services behave when you're working within ArcGIS. If you don't already have access to ArcGIS and would like to experiment with some of these, I have copies of the ArcGIS disk that are available for students to run on their computers during the current term. And also there's a downloadable version available to students enrolled at the university as well. So if you'd like to obtain a copy of that for use for the class, just let me know and we can get you the information needed to be able to experiment with ArcGIS on your Windows computer. ArcGIS is only available to run on Windows. So in conclusion, as we talk about the integration of OGC services into your desktop GIS application, the key thing to remember is that the GetCapabilities request that we've been working with all semester as we're interacting with these services is the key for configuring your client application to productively interact with those OGC services. So it's not just the manual interpretation that you've been doing so far of those XML files that you can see the information about the service, but that's the information that is used by your computer to configure the clients that might interact with those same services. That having been said, being able to read and understand the capabilities request itself can help you in troubleshooting instances where there is a misconfiguration or an inability to connect to a particular service. While we've seen two examples in Quantum GIS and ArcGIS where you provide only the base URL for the GetCapabilities request, there are instances in other client applications where you might need to provide the full GetCapabilities request, including the service and request parameters that you have previously worked with and that are often the full GetCapabilities requests that are published or placed online for given OGC services. So we've already talked about how clients automatically configure themselves, but depending upon either incorrect information in the capabilities document itself or issues in the implementation of support for the OGC services, there will be instances where there is a misconfiguration of the client application that is based upon the GetCapabilities XML response. You can, if you understand the sort of nuances of the misconfiguration, you could conceivably create a copy of a GetCapabilities request, edit that capabilities request, and save it in a location that you can then point to from your client application. But that's a difficult challenge, and it then decouples that document from the actual capabilities of the server and is then going to be very easily broken the next time they modify the server. So more often than not, if you encounter a misconfiguration that's being advertised as a part of the capabilities request, you're probably going to be stuck with that, and you just need to potentially find an alternative server to interact with that might be hosting the same data that you're interested in. So that concludes our discussion of interacting with OGC services and desktop clients for this week. And I hope you will enjoy experimenting with Quantum GIS and interacting with services as we move towards the later stage of the course, where you will be generating your own services and also integrating those services with any others that you have found that you want to use in your class project.